Okay, so this is quiz 7B here. What I did during the 11 a.m. was I went over the product rule proof and then a quotient rule proof that wasn't the rabbit proof. So what I'm going to do is I'm going to say, please go, if you're interested in the product rule proof, and that's the one you want, please go watch the video. Because what I'm going to do is I'm going to do the quotient rule proofs. The quotient rule proofs instead. So all of this is on the video for 11 a.m., which is already posted to YouTube. Yes. So you can watch it. And I go through all of these things and why the strategy is so important for this. And then I've also got, and obviously I need to move it a little bit. So what I'm going to do is I'm going to go over the quotient rule proof with the rabbit. And then I'm going to go over another way to prove the quotient rule. Okay. So is everyone on board with this? And let me show you how important this is here. Why write a strategy? I have not looked at this proof beyond looking up the strategy. Okay, I looked up the strategy on my. It should actually be the other way, shouldn't it? I looked up the strategy on the rabbit about 10 minutes ago, and that is all I have done. I have not looked at the proof at all. And I am going to rebuild this proof for you without having looked at it in forever. No, really, I haven't looked at it since I did this last year when I did this quiz. Okay, it is that long ago. So, or last semester. So, what we're going to do, no guarantee that the tablet will work on us. Come on, zoom. It'll pan. It won't zoom. I'm sitting here going like this. Now it works, of course. Okay, so what I'm going to write is I'm going to write the steps here, the strategy. And again, I haven't looked at this in a year, so it might be embarrassing. But I'm going to say what I want to do, and I say I'm going to use the F definition of the derivative, expand, take a common denominator at the top, add the rabbit to the top, group split, and use the limit laws to break out. Since g is continuous at x, g of x plus h goes to g of x, and there's my rabbit. Haven't looked at the proof. Just looked at the strategy. All right, let's see if I can do this. And this is what I mean by you don't memorize a proof. You memorize a strategy. I'm just going to follow my directions. All right, so f over g prime of h equals, I'm going to use the definition here, the limit as h goes to 0, f over g of x plus h minus f over g of x all over h. And that equals the limit as h goes to 0, f of x plus h over g of x plus h minus f of x over g of x all over h. Now I'm going to take a common denominator like I said I was going to do. And when I do that, I get the limit as h goes to 0. Let's see here. I'm going to get f of x plus h times g of x all over g of x plus h times g of x minus f of x times g of x plus h over g of x plus h, g of x, all over h. Equals the limit as h goes to 0 of f of x plus h, g of x, minus f of x, g of x plus h, over g of x plus h, g of x, all over h. Now, because I wrote a thing that said I was going to take a common denominator, I could have actually gone straight from here to here and skipped that step. Because I wrote a strategy, I could have, this step was optional. I could have skipped it. I mean, it's there, but I could have gone from there to there because I said I was going to be taking a common denominator. And that's where that g squared is going to come from. Okay. Now what I'm going to do is I'm going to add my rabbit. Okay. This right here has a g of x in common. This right here has an f of x in common. So now I'm going to group and factor. So I get limit as h goes to 0, f of x plus h. This term right here becomes this term, so I've got a g of x in common. And then over here, I have a f of x in common. And this term is going to become the front term. And this term becomes the back term. So let's do that a little bit more neatly. So this term, this right here has an f of x in common. So I'm going to factor it out. Okay, now what I'm going to do is I'm going to multiply this through by -1. So I'm going to put a plus there, minus there, and a minus there, because I know I want that minus in the end. That's a little trick I probably should have put in my intro, because I might have forgotten that. All right, now I could split everything up. I've got this piece here, and this piece here. Okay? So what I'm going to do is I'm going to put this piece with that piece. I'm going to pull this out. So I'm going to wind up with g of x over g of x plus h times g of x. And I could cancel, but I don't need to. Times f of x plus h minus f of x all over h. Minus the limit as h goes to 0. These two terms flip when I do this. I mean, they'll flip when I do this. That happened when I did that. So now I'm going to have g of x plus h, g of x times g of x plus h minus g of x all over h. And that's going to be done with the sum law. So these two terms get flipped. And that term didn't express over there, and that term came out in front right there. Okay. All right. That there, this term right here, I could pull everything out with the product law. Okay, so this becomes the limit as h goes to 0 of g of x over g of x plus h, g of x, times the limit as h goes to 0 of f of x plus h minus f of x all over h, minus the limit as h goes to 0 f of x over g of x plus h, g of x, times the limit as h goes to 0 of g of x plus h minus g of x all over h. Okay. This term here, since g is continuous, this goes to g of x plus 0. Right, so I just kind of give a little thing. Now, I actually don't need to do this because I did it in my introduction. So this here becomes g of x over g of x squared times f prime of x minus f of x over g of x squared times g prime of x. And that's a common denominator, so I'm done. How do we feel about that 1 to 5? Ooh, I need to ask the question, don't I? Polling, multiple choice. And then I'll inevitably get the question, do I have to prove this on the test? And the answer is you might have to do one of them. Historically, we've given you choice. I don't know what's going to happen this time, but it's asking you to prove the study guide is asking for proofs of product, quotient, and power. No chain. For product and quotient, so for product, you only have the rabbit proof. For quotient, you can use either the rabbit proof or these other ones I'm going to show you in just a moment. But you can't use the log proof for either of those. And then the power rule, you can choose which power rule you want to do. So there were like 4 different power rule proofs. You get to pick one. But make sure you state what you're assuming has already been proven. Are there any questions about that? And as I said, if you watch the other video, you'll see me go on and on about what's going to be on the which options are on the test for the proofs. Okay, now it's not working at all. There we go. There are a couple of other ways to prove the quotient rule. So I went over the one with the reciprocal rule in 11 a.m. and I also did this one at 11 a.m. But let's go over this one real fast. Because this one's kind of slick. You know what? Let's just leave it. Oops. What'd I do? All right, so this one's a little slick. Let's talk about this. This is another proof of the product rule, the quotient rule. So what I can do is I can use the chain rule and the power rule to do this. And here's what I mean by this, okay? So my strategy, so I want to show that d over dx of u over v equals u prime v minus v prime minus uv prime all over v squared. And my strategy, use product and chain rule. On u v negative 1. And that's the key, is that this whole thing is uv negative 1. All right, so here's how that proof works out. I go d over dx u over v is the exact same thing as the derivative of u v to the negative 1. And now I apply the product rule, and I get that I take the derivative of the first, d over dx of u, times v to the negative 1, plus u times d over dx of v to the negative 1. Now, note I've got a little chain in here going. So I'm going to deal with that. So the chain here is that this is v. So the chain here, okay, so d over dx of u is just du over dx, otherwise known as u prime. This is v to the negative 1. I'm just going to go ahead and write u prime over v. Plus, and I should have said take a common denominator, I guess, in my strategy. U times, now the derivative here needs to be d over dv of v to the negative 1. Here's the chain, times d over dx of v. That's the chain. So now I got u prime over v plus u. Now the derivative of v with respect to itself, I apply the power rule here. I'm sorry, the derivative of v with respect of v negative 1. The derivative of v to the negative 1 of v is negative 1 v to the negative 2. And then I've got a dv over dx, which just becomes v prime. Now this right here, this 1 is going to come out. Oops. This 1 comes out, and this piece right here goes down to the bottom. So I wind up with u prime over v plus, minus, because I've got a negative 1 now floating around, minus u v prime all over v squared. And then I just take a common denominator and I get u prime v over v squared minus u v prime over v squared, which equals u prime v minus u v prime all over v squared. How do we feel about that proof, 1 to 5? Let's see. Why isn't it starting? There we go. So that's a little bit of a slick way to do it. You just take a little power rule, a little chain rule, and you just kind of plop it up. And it's easier to do this one if you use U's and V's instead of trying to use F's and G's. Because if you use F's and G's, you're going to forget that there's an outside there. So the key to this proof is don't forget there's an outside. Okay. There's another proof that you can use, and you haven't seen this one at all yet. But why not? And this is a Calc 2 style proof. So a bunch of the proofs in Calc 2 look like this, and you don't need to memorize this. You don't even need this proof. But the trick is to let Q of X equal F of X over G of X, and do algebra and product rule. So what you do is you basically differentiate both sides, right? Or implicit differentiation. Okay, so this is the implicit differentiation proof. What I do is I say, okay, Q of X equals F of X over G of X. And that means G of X times Q of X equals F of X. Now I take the derivative of both sides, and I get d over dx of G of X times Q of X equals F prime of X. Okay, so now I'm going to do the product rule on this side, and I get G prime of X times Q of X minus G of X, plus G of X Q prime of X equals F prime of X still. All right, now I'm going to solve for Q prime of X, because that's kind of my dy over dx thing. Okay? So now what I'm going to do is I'm going to move this. I'm going to solve for Q prime of X. And what I'm going to get is the following. So I'm going to get, here's F prime. I'm going to get rid of this first. So I'm going to do G of X times Q prime of X equals F prime of X minus G prime of X times Q prime of X. Times Q of X. And then I'm going to divide both sides by G, and I get Q prime of X equals F prime of X minus G prime of X times Q of X all over G of X. Now, what I'm going to do is I'm going to, okay, so I need to solve for that. I need to institute that. So recall Q of x equals f of x over g of x. So I basically sub back in for my y. It even would have been better if I used y as the term here. And I get q prime of x, as it really is just an implicit differentiation proof, f prime of x minus g prime of x times f of x over g of x all over g of x. Now what I'm going to do is I'm going to take a common denominator on top. Right, so now I've got g of x. I can combine the top, f prime of x, g of x, minus g prime of x times f of x, all over g of x, all over g of x. And that, of course, I slide that down to the bottom there because what I do is I multiply by the reciprocal. So this thing is going to be times 1 over g of x. And I wind up with f prime of x, g of x minus g prime of x, f of x, all over g of x squared. Probably would have been better with u over v's. But that's another one. So I probably could have done this with a y and a u over v. It probably would have looked a little cleaner as just an implicit differentiation proof. Okay, how do we feel about that one? Let's see. Excuse me. One to 5. It's less clean because I used G and F instead of using U and V. I probably should have, if I had used U and V, it would have been a little bit better. Just thought. I might want to do that as kind of another way to do it. I don't want to take time now, but maybe I'll post a video about that. Maybe. Okay, the point is that there are lots and lots and lots and lots and lots of ways to do this. Okay, let's look at these problems here. All right, so this thing, the journey of x here, x has a lot of convoluted journey, but there's this x, negative x, 2 to the negative x times 2 to the negative x here. So the outer thing is a product. I'm going to take the derivative of the first times the second plus the first times the derivative of the second, and I'm going to call that little negative x there u. Yada, 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 yada. I get 1 there. 2 to the negative x is baggage. X times, this is my chain, d over du, 2 to the u times d over dx of u. And so I get 2 to the negative x plus x times the log of 2, which is the, remember, that's that little constant that gets generated by the 2 to the x bits, times 2 to the u times the derivative with respect to x of negative x. And then I just, I sub back in my u and I get 2 to the negative x there. And of course, there's a negative 1 generated by that. How do we feel about that one, none to 5? So we've got, let's see here. This is 2a. I just realized that you guys haven't been able to see what's been going on, how people have been feeling this whole time. I'm not sure how I feel about that. Okay. All right. The second one looks mean, and the test has a lot of these, okay? So the test always has a bunch of these that looks mean but aren't. This 2 to t to the 3, this is just a product rule problem. There's the product rule. There's the, you have to recognize that this is just a product rule problem. And then you need to not mess up that negative sign. And it's common here to wind up with a negative 3/4. Don't do it. It's negative 1/4. It's also common to put the 1/4 in front instead of the 3/4 because you're in a hurry. Don't do it. Take your time. How do we feel about 2b there? Wonderful. Let's do this multiple choice. So how do we feel there about 2b 1 to 5? All right. Moving on. Let's look at this last one. This one's hard. This one is genuinely hard. This one requires a log diff. And you could tell because both the base and the exponent are moving. Okay? So we're going to let y equal x to the log x. Now, there's two ways to do this. In the morning one, I did this is the chain rule way to do it. So let's do the product rule way to do it. So let y equal x to the ln of x. And what I'm going to get then is I'm going to take the log of both sides, and I wind up with ln of y equals the natural log of x to the ln of x, which equals ln of x, because this comes out in front. No calculus, the only thing that's happening is algebra here, times ln of x. Now, I can make that ln of x squared, which is what I did before, but I'll just do the product rule this time. So I'm going to take the derivative of both sides, d over dx of ln of x, ln of y, equals d over dx of ln of x times ln of x. Okay, and this side is going to be a product rule, so I'm just going to do that. And this is going to be d over dx of ln of x times ln of x plus ln of x times d over dx of ln of x. Okay, so this right here is going to become 1 over y dy over dx. And that equals this bit. Well, the derivative of this bit is 1 over x. Ln of x plus 1 over x ln of x. And because I absolutely cannot help myself but simplify this, right? 2 times ln of x over x. Just because I can't help myself. It's like staring at me going, stare it. And I'm giving in. All right, now what I need to do is I need to move y over to that side. And I wind up with, let's get rid of the marks because they're distracting. And I wind up with dy over dx equals y times 2 times ln of x all over x. And then I remember that y, what did y equal here? Y equals x to the ln of x. So I'm going to stick that back in front. And I get x to the ln of x times 2 ln of x all over x. And if I'd done it the other way, I would have gotten the exact same answer. Okay, so one to 5. And if you want to see the chain rule way, again, it's on the 11 a.m. Any questions? No, if you didn't simplify, not only is it not wrong, it's better and I like it better. If you didn't simplify, I like it even more. As long as you subbed in your y, you have to sub in your y. You make y. If you createth y, you taketh away y. Okay? If you giveth, you taketh away. Okay? You are the alpha and omega of y. You make it, you destroy it. No genesis of y without a revelations of y. How's that? Or I guess Daniel if you're Jewish. Any other questions about this? Okay. All right, so that's the end of the quiz. Let's talk about the problem set.